Okay, now let us look at the new topic called computer system architecture. It is just an introductory part we are going to have, just to look at like how operating system works with this concept, architecture of computer. Okay, so we have understood that with every computer there are certain resources. There are certain resources, and out of that, the most important computing resource which we can say a brain of computer is a processor. Okay, so we are going to have a processor here as most important resource, and based on the processor, which is nothing but a computing element, so we will say this is a computing element, and with this particular computing element um, uh, functions for producing certain task or executing certain task as supplied by user. This is one, or as it is being initiated by a operating system. Okay, so the processor plays an important element. So it performs all sort of tasks like computation, complex computation, processing, and all that. So this processor requires processes to be generated. This processor required processes to be generated and executed. Okay, processes to be generated and executed. So the most of the system in a computer, general purpose, like whatever computer we are using, they are using a single general purpose processor. Okay, so means they are like in general, and in most computers we find uniprocessor system. Uniprocessor, uni stands for one. Okay, have only one processor. Okay, so but this is not the ultimate computer we are going to have. We are going to have a multiprocessor systems also. Okay, so in case of a multiprocessor system, they are like whatever the task that is being provided to a one processor. Just imagine that if you have a multiple processor, P1, P2, P3, P4, right? Your computer having more than one processor installed, right? In that case, the task which is being supplied to a particular processor, so you have like a parallel systems, right? So your task is going to get executed parallelly. Results are being like if you work in parallel, the time required for completion of the task will be is going to be minimum, right? But if in order to do this, we have to consider that the task should be independent in nature. There should not be dependency. If dependencies exist, then definitely the system is not going to be a parallel system. So you have to take this case, right? So just to have a better understanding, see for example, there is one student, and you have say for example 1,000 postcards, right? And these 1,000 postcards are to be sorted into say A class, B class, C class, and D class. Okay, so there are four number of defined classes, right? And there is only one process system which is processor is working on this. Okay, so it requires T time, right? It requires T second time, right, for one system. Just assume that this system is being modified in this way. Say the same thing is there, but with this particular student, you have two students. That means what? This is T is going to be divided by 2. If it is 3 student, T is going to be divided by 3. If it is 4 student, it is going to be T by 4. Okay, now here, if it is say A, it is say B, C, and D. So for A, B, C, D, this is shared memory. This is going to be a shared one. This memory is shared memory. And A, B, C, D, these classes are not dependent on this A, B, C, D, right? So these are not dependent on this, right? So any or A dash can put the card into A, B, C, D. B dash can put a card into A, B, C, D. C dash can put a card into A, B, C, D. D dash can put a card into A, B, C, D. But if we make it more restrictive, so means if D has got a card, A card, so D cannot put the card into A. So means what, the work is going to get dependent, right? So when you have such kind of architecture and which is working into a parallel, so you need to work with we need to work we need to consider one most important criteria, and that criteria is you should have independent processes, right? You should have independent processes. It means that these processes are, the execution of the processes is not dependent on each other. If such a system is there, then we can go for parallel systems. Okay. Okay, so the advantages include that it increases the throughput of the system. So here you can take this as a performance measure. This can performance measure. At the same time, the economy of scale, and it increases the reliability of the system. So means what, the fault tolerance get lowered down. Okay, so it has two types actually: symmetric multiprocessing and asymmetric multiprocessing. Right. So what is going to happen? Say in case of symmetric, each processor performs all tasks. Right here, A dash, B dash, C dash, D dash can sort the postcard into A, B, C, D. Right. It is a symmetric kind of processing. Asymmetric processor means each processor is assigned to a specific task. Means say for example, A dash can sort only A cards, B dash can sort only B cards, C dash can sort only C cards, D dash sort only. Okay, means if unfortunately, if say A receives D card, A receives D card from this postcard, it again will throw it back to this and search for A card so that it can point. Okay, so means what, it is in this particular case. So you have a symmetric kind of processing and asymmetric kind of processing here. Okay, so each processor is assigned to a specific task. So A processor assigned to sort only A card, B processor assigned to sort only B cards, C processor assigned to sort only C cards, likewise. Okay, in case of symmetric processing, each processor performs all tasks of sorting. Say for example, irrespective of ABCD, it classify those 100 cards, whatever there, so it is in that particular case. So means what, if suppose there are 1000 cards, 4 participating processes are there, then you have to go for load balancing also. Right, you have to go for load balancing also, which means like say this 1000 postcards, so ultimately there are how many operation? 250 operation each, right? So means what, it is being reduced. So every participating processor has to sort only 250 cards. So the load is balanced equally amongst all the participating processors. But here, please try to understand that this works well if it is independent. Okay, this is one. The most important thing is that in case of most of the uniprocessor system, the utilization of processor is not to the maximum level, right? So like we used to take a higher end configuration for our laptop, right? So but we are not utilizing the proper resource. So in that case, it is highly expected that you should decide your mechanism in such a way that you can manage all those resources properly. So this is important. Okay, let's go up to the next. So if you look at this multiprocessing architecture, you will find that this is a CPU 1, CPU 2, CPU, right? 0 CPU, 1 CPU, 2 CPU. With each CPU, what we have learned is that we have some registers and cache. So with CPU, we have a cache memory with everyone, right? And this particular memory is being a shared memory. This is being a shared memory. So this is the common memory in between all. So this is the general multiprocessing architecture. So either this can be done into this work can be done into symmetric way, symmetric, or this can be done into asymmetric way, right? Okay, in case of asymmetric way, each processor has a particular work assigned. In case of in case of symmetric way, everyone can do all sort of work. Okay, this is important. Okay, now right now we are using a dual core architecture, core to DO, and all that architecture. What it indicates that you have a chip, a multi-chip and multi-core architecture. So like here the cores are being defined. So if this is the CPU chip, so on this particular CPU chip, so it's like this kind of mechanism. This is one core. This is going to be a second core. This is going to be a third core, right? This is going to be a fourth core. It is like this. So it is this is one processor here, second processor here, third processor here, fourth processor here. So you cannot put it side by side, right? So in order to just reduce effectively use the space of the board, so people thought that let us try to prepare a course so that multiple CPUs can be put one after another, right? So it's like it forms a core, something like this is core one, this is core two, and likewise. Okay, so this is can be done. So for all these cores, every core has, say, this is zeroth core, this is one, this is two, this is three, and with all you have cache, right? One cache, two cache, three cache, right? And they are going to connect with one only primary memory. Okay, so this you need to understand. Okay, so this is the dual core design. Now, if you look at a clustered system, it is very easy, right? In case of this clustered system, you can say that you can build a Linux cluster, right? You can build up a Linux cluster, or you can have Windows cluster if you can think, right? Okay, you can have a Unix cluster likewise. So the computers are interconnected together. The computers are interconnected together. So each computer has its decision. Like each computer has a processor. Each computer has a memory. Okay, so this has again its own processor. This has its own memory. Okay, so this has again a processor and memory. Right. So they have their own storage also. So there is one storage also, right? But it is preferred to have a storage area network, that this is called as SAN. SAN is a storage area network. This is a common storage for all. for all computers. This is a common storage for all computers. Okay, so based on this, you can have a different architecture which you can study into computer system architecture subject, CSA subject, right? Which this is out of the scope right now, but like there is architecture like single instruction, single data, single instruction, multiple data, multiple instruction, multiple, all those architectures you can think of, right? Then you can have a shared memory or non-shared memory, right? Shared or unshared architecture. On that you can build a system. But the objective of this particular clusters here is to perform parallel operations, to perform a parallel operations. This is the case, right? And this has a uh, collective collective power of processing, right? Collective power of processing means, say for example, I have this CPU 1 2 3, computer 1 2 3 are say five are a Pentium, right? A Pentium computers, right? Pentium computers, right? And these Pentium computers, like say they are 586 computer, but say dual core architecture. So dual core architecture. So all these three. So it means what? How many processors you are going to have? So with each dual cores means 2 cores of processor here, 2 cores of processor here, 2 cores of processors here. So collectively you have got 6 processor in line here, right? So like say you just imagine like how much power that they are going to have. Okay, so these type of cluster systems are uh, well suited for this well suited for complex operations, complex operations such as weather forecasting, right? Such as weather forecasting. Then you can go for say genome analysis, right? Then you can just think of like big data analytics. Also, you can use big data, right? So these are this sort of cluster systems you can use accordingly. Okay, so this is what you need to understand. With the two important terms which are multi-programming and system. Okay, so what does a multi-programming is concerned? If you are working with a single program, the system is called a single programming system. Okay, the purpose of like say if you remember single user single tasking system, you know, single task. So you can refer it as a SUST kind of system. So it is uh, single user single task, right? So means at an instance of time you can this system can perform oblique execute a single task at a time, at a time. So people thought that this sort of system, if I'm able to execute only one task at an instance of time, which is actually poor utilization of resources. So people thought that we should at least execute multiple programs. So we can execute multiple programs, if this does, then there is a rise of uh, multi-programming system. Okay, so in case of a multi-programming system, uh, 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 CPU can execute multiple tasks using multiple programs using a job scheduling mechanism, right? So the efficiency of this particular system is increased. You have an increased efficiency. See, and you have effective use of resources. You have very effective use of resources. Okay, this is important. Now next is like, okay, if we are able to execute multiple programs. Now for example here, uh, for example, I wanted to work on Microsoft Word and Excel, right? So Microsoft Word is one process, Excel is one process. So this is a program one, this is program two. So both programs are different in nature. Their code and data is also different. So they have their own code and they have their own data are also different. So which means that by data I mean this Microsoft Word works on .docx file, and this Excel works on this process one, process two can exchange information. Say means I wanted to take a data that is present into a table form of Excel, wanted to have into a Microsoft Word. So this is being possible by using OLE. So here OLE stands for object linking and embedding. So you can embed different objects all together into one another, right? So when these two programs are running independently, right, then you are going for a multi-programming system. So this is a very good example of multi-programming system, right? So by their code I mean the processes that they have, right? So by code I mean the processes they have. So they have different processes altogether, right? And in this case, there in though this is the task which is being generated, this Microsoft Word has its own different processes that are running independently. Say for example, spell check, grammar check, right, and formatting, right? So these processes are independent, right? They're different. Okay, so in this case, you can go with the multi-programming system. Okay, and whenever say, for example, if you look at that, if you look at mechanism that you have example, this is connected to your system. So if suppose Microsoft Word sends a printer document to a printer, Excel is also sending a document to a printer. So here it is using a buffer, right? And this is, it says that Word document and Excel document. Okay, so means what? So if this device is available, the Word gets printed. If the device is available, Excel gets printed. But at Excel, at the printer side, it is buffered. But when in case of Microsoft Word or in case of process program, when it has to wait for some IO operation, OS switches to the another job. So means like it is like, okay, so still till Microsoft Word document is printing, Excel is in wait state. So it is like that. So in case of time sharing system, it is a logical extension in which a CPU switches jobs so frequently that user can interact with the jobs while they are running. So it creates the interactive computing. So say for example here